Hello everyone. So in the last video we have seen how we can use a variable inside the for loop to take advantage of its varying value. Okay, that means how we can use I inside the variable, and even we have printed this looping numbers right from 1 to 10 using the variable value. Also we printed from 1 to 100 using I. Okay, now let's do the same thing. Okay, let's take the advantage of this variable value and let's try to switch on LEDs one after another. Okay, let's try to switch on 5 LEDs one after another using for loop. Okay, so let's take from pin number 3, 4, 5, 6 and so on. Let's have 5 LEDs and try to burn them, that means eliminate them. I'm sorry. So earlier how we were writing that scenario, we will write digital write 3 high, okay, and a delay of let's say 400 millisecond. Sorry, and again copy. We were repeating the code, right? We were repeating the code. How many came? 5 came now, right? So we had it 4, that means this one. We had it 5, we had it 6, and we had it 7. Okay, 3, 4, 5, 6, 7. Okay, that means 5 LEDs. Okay, with the delay. But you can see the same two lines are repeating one after another. There's no doubt. Only thing that changes is this number 3, 4, 5, 6 and 7. Okay, 3, 4, 5, 6 and 7. So now we know how we can pass a variable, okay, varying value, how we can loop it with a varying value. So now you know we can take this part and have a for loop and we can loop it, only changing this value. Okay, so we don't need to write all these lines now. So what I will do is I will copy only this part. I will remove first everything. Okay, and I'm going to have it here. Okay, so I will change the 3 value as I, because I has to change from 3 to 7. Okay, that's the purpose. Okay, 5 LEDs, number 3, number 4, number 5, number 6 and number 7. Okay, so now, okay, what will be the I values? Initially I is 1 and ending point is 10. Okay, so I will be from 1 to 10. Okay, 1 to 10, but the number 1 LED from 10 LED will work, but my purpose is 3 to 7. Okay, so I have to change these values according to my purpose, isn't it? It should start from 3 and end at 7. Okay, logically talking. Okay, so what I will do is I will make this I value as 3 initially. So now what you should do is you should remember the flowchart diagram that I have explained earlier. For the sake of now I rewrite it. Okay, so I change the I value as 3 now. You have seen that. In 4 we will have condition. So this is not a code, this is the flowchart diagram. Okay, workflow diagram, let's say. Okay, wait a moment guys. Okay, so let's add I plus plus also here. Okay, so now let's start from 3. That means I value is initially 3. So get 3. So when the first iteration comes, I will be 3. Okay, 3. Then where should we end? When it is 7. When it is 7, we should come inside and we should switch on 7 and then we have to break it. That means 7 will be incremented to 8. So when it becomes 8, we have to break. So what I will do is I will keep the less than or equal and I will change it to 7. Now what will happen? For 3 up to 7 it will work. 7 also will be included because we have the less than or equal sign. Okay, 7 also will be there. When it's become 8, that means 7th iteration, 7, when I is 7 iteration will happen, then I will be made to 8, then it will break because it is false. I is less than or equal to 7 is false now when I becomes 8. So then you can see from number 3 to 7 I value have changed and the iterations have happened 5 times. So I hope you understood because we have seen these things from previous videos. So obvious. Okay, so if you want, what you can do is you can simply have this condition here and compare with the workflow for which I values Okay, starting from ending, we will get inside this void loop. And we here what we do, we eliminate the LED, right? What is action? We eliminate the LED of that particular I value. So you will see from 3 to 7 LED will be switched on. So as an exercise, you can find the I values for which this for loop will work and for which I value it is going to break. So you will find the I value will be 3 to 7 if you do it. So just try this out, okay, with the workflow diagram. If you don't understand, if you have seen my previous videos, obviously you will understand this. Okay, so now this is great. Okay, so but there is one thing is missing here. What is that? You know, when you are doing a digital write scenario, what you have to do, you have to mention the pin mode. So I will remove the serial begin because we don't want it. Okay, you will mention the pin mode. Okay, so normally what we do, we want it to be 3 to 7, right? So we will say pin mode 3 in sorry, not input, output. Yes or no? Yes. And we repeat it. I'm sorry, what did I do? We repeat it. How many times? 5 times. 3, 4, 5, 6 and 7. Okay, 5 times we repeat it. Okay, then yeah, pin mode we have done. Then we can do the digital write thing. But if you are smart enough, what you can do, here also you see the repetitive thing is happening. 3, 4, 5, 6, 7. Okay, so what we can do is we can copy this pin mode and we will paste it before the digital write inside the for loop and we will make it I. Okay, so what you will do is when the I is 3 we will do the pin mode I is output, pin mode 3 output, then we will digital write that particular pin. 3 will become high, then 400 millisecond delay, then I becomes 4 now. Okay, I become 4 because I is incremented. At the time this I will be 4, that means second line will be implemented. Then we will switch on the second LED, then delay 400, then I is 5, so here pin mode 5 output, this will be implemented, then digital write 5 high, that means 5 will be on. Okay, then in the next iteration I will be 6, so here pin mode 6 output, this will be implemented, then we switch on the 6, so when pin I is equal to 7, the last time we get into the for loop, so pin mode 7 output, so this line is implemented and then we switch on the LED. So you see, if we have it inside the for loop, we can manage with one line. We don't have to write all this line. At the same time, we don't have any issues because before switch on that particular LED, we set the pin mode to output. Earlier what we did, we set all these pin mode to output and we switch on everything one by one. Now since we put in the for loop, before switching on that particular LED, we made that pin mode as an output. Still no problem, right? Because that particular pin become output before we switch it on. Before we switch that particular pin, we mention it as an output. We have done it. So no problems will come. You understand what I'm telling? Okay. So we say pin mode and we say digital write. We say pin mode and we say digital write. We say pin mode, we say digital write. We say pin mode, we say digital write. We say pin mode, we say digital write. So one after another. So no issues will happen. Only the small flow change. That means we don't, in a bulk way, we don't give all the outputs mentioning first and we switch on everything next. Instead of that, one by one we give the, say this is the output, then we switch on. So no issues will come, right? So we can remove these lines as well. So now you understand how cleverly with single line using a for loop I have managed the 5 pin modes, and how cleverly with a single line using a for loop I have managed 5 digital writes. Okay, so now you can see how beautiful the code has become, how the code redundancy have been removed using a for loop. Okay, only one line for one scenario. Okay, so guys, we will continue further in the next video with the demo. Until then, stay safe.